Hey everyone, and welcome to the course. My name is Daniel Buckley, and I'll be your instructor. In this course, we are going to have an introductory look at the Unity game engine. Now, the Unity game engine is a cross-platform game engine used by millions of people around the world. It is an incredibly versatile game engine, allowing you to make games in pretty much any format and platform possible, such as 3D games, 2D games, mobile games, console games, multiplayer games, virtual reality, and augmented reality. Okay, so any sort of game you want to create, you can do it inside of Unity. And likewise, you can build it to pretty much any platform you can think of. Desktop, mobile, even TV and console platforms you can build to with Unity. Now in this course, we are going to go from the ground up, from installing the engine to creating your first ever game. We're going to start off by learning the Unity editor. We'll be looking at what each of the different buttons and components and screens do to have an understanding of how the engine works. We are then going to learn about many of the different engine features, such as GameObjects, moving, rotating, and scaling them. We'll look at object parenting, prefabs, materials, and a wide range of other things as well. We are then going to learn scripting. This is going to allow us to start coding in gameplay behaviors to make our objects and games work in the way that we want them to. Now, in terms of course requirements, the only thing that is required is that you have a computer which can run the Unity engine. Okay, the Unity engine is going to be a few gigabytes in space, so do make sure you have enough space on your computer for that, as well as internet required to download the engine. Apart from that, there is going to be no prerequisites required at all. We are going to be learning the engine from basically nothing, having no understanding of how it works, to having an understanding that you can actually go ahead and create games. The same thing for the programming. You are not required to know anything about programming at all to complete this course, as we are going to go from the very, very basics of what variables are and how to write down code. Okay, so if you're a total beginner, then this is the right course for you. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Now let's get started with the first lesson. Hey everyone, in this lesson we are going to be looking at installing the Unity Hub. Now the Unity Hub is essentially the launcher for Unity. This is a program where we can install different versions of Unity as well as create and manage all of our different projects. So let's now go over to unity.com where we will begin the installation. So here I am at the unity.com website, and what we're going to do is go to the top right corner where we have the blue Plans and Pricing button and select that. This is going to bring us over to this screen here. We want to go down to where we have the Personal Unity Edition, which is free, and click on the Download Now button. This is going to then take us to the Download Unity page, and we then want to click on our appropriate download button here for whatever operating system we are on. If you're on Windows, it should say Windows, or if you're on Mac, it should say Download for Mac. So I'm going to click Download for Windows, and that is going to begin downloading the setup. Now, once that has completed, simply open up the installer and go through the process. So we'll go through our installation process, choose the location we want to download this to, and then click Install. Once that has been finished, we can click on Finish and then open up the Unity Hub. Now, when you open the Unity Hub for the first time, you'll be welcomed to the Sign In screen. What we want to do here is go down to where it says New to Unity and select Create Account. This is going to take us to the Unity website where you can go through the process of account creation, and then once that has been completed, we can click Sign In. Once you have successfully signed in, we'll be taken over to the Unity Hub. Now, one of the first things you'll see is a little prompt saying Get Unity Personal. This is just going to activate a license for us for the Personal Edition. So we want to click on Agree, and then we'll be taken to the Installs page. Now, Here on the installs page, what we want to do is essentially install a new Unity editor. This is going to essentially be the software that we launch into in order to develop our Unity games. So I'm going to click on Install Editor, and it'll open up a window here. Now we are going to select the recommended version here and click Install. We can then choose to install additional modules. Now, if you want to have build support for Android, iOS, Linux, Mac, you can go ahead and enable them there. You can see their appropriate download size on the right-hand side. But for us, all we need to do is make sure that Microsoft Visual Studio is enabled here, as that is going to be the software where we are going to be writing our code. So let's then click on Continue, agree to the terms, and then click Install. Now this is going to begin the download process. We can click on the little blue button up here to see our downloads and how that progress is currently going. So once that is finished, in the next lesson, we are going to go over how we can actually then create a brand new project. So thanks for watching, and I'll see you all then. Welcome back, everyone. So hopefully by now your download has completed. It can take some time as Unity is a few gigabytes in size, so do wait until that has finished, and on the install screen you see your Unity version right here. Make sure that you can see that before continuing on. So now that we have the actual Unity engine itself installed, we can create a brand new project and jump into creating some games. So I'm going to go to the top left corner to the projects window here. This is where we are going to have a list of all the projects that we have created. We can basically open them from here, we can delete them, we can even change and update the version that they are in. The Unity Hub is, as it sounds, a hub. This is where we go to basically launch into any project we want. So I'm going to click down here on the new project button, but once you have projects listed out here, this button will not be available anymore, and we'd have to click on the one at the top right corner. So I'll click new project, and here is where we want to select our template. Now you'll see there are many different categories. I'm going to select core, as these are the core templates that Unity has to offer. But what is a template? Well, essentially a template is just a way of Unity setting up the editor in a certain way for you to begin creating games. So you can see here we have 2D, 3D, we have high definition 3D, mobile, VR, AR, etc. Now, if you say, for example, create a 2D project here, and later on you're like, hey, I actually want this game to be 3D. Well, luckily for you, these templates are not set in stone, okay? A template is just the starting conditions for the Unity editor, and you can pretty much make AR, VR, 3D, 2D, all in the same project, jumping between whenever you wish, okay? So this is just here to establish the starting layout of the editor. So I'm going to select on Universal 3D, and then on the right hand side we need to fill in a bit of information. First of all, we need to select a Unity organization. This is essentially going to be your Unity account. So select that from the list here. Then we want to give the project a name. I am going to call this one Intro to Unity 2025. Next, we can choose a location. I recommend setting up a folder on your computer where you're going to store all of your Unity projects. So here I've gone ahead and created a Unity projects folder. Then what we want to do is go down and click the blue Create Project button. You may have this prompt appear. Simply agree to the terms and accept and continue. And from there, the Unity engine should then begin loading up. It can take some time. Generally, if it's a brand new project, it's got to basically establish everything, so it may take a few minutes, but once it is done, we should be in the Unity editor. And now here we are inside of the Unity editor. In the next lesson, we're going to dive into the editor and have a look at how it all works. So thanks for watching, and I'll see you all then. Hey everyone, so when we create our Unity project, we are going to open up the Unity editor. Now, the Unity editor is the program where we are actually going to construct, test out, and finish our games. So at first glance, it may look a bit confusing. There's a lot of different windows and panels and buttons and bits of text, but let's go over what each thing does. Now, the most basic understanding of the Unity editor is that it is divided into a number of different windows. Okay, you can see over here we have the hierarchy. Here in the middle we have the scene window. On the right is the inspector, and down at the bottom we have the project window. Okay, all of these are different boxes that are constructed to build out the editor. Now, each of these windows serve a specific purpose in our game development journey, and we'll go over what each of those do in just a second. But something you might want to know is, for example, how do I change the layout? Well, you can click and drag on the borders of these windows to basically change their size, so you can adjust exactly how you might like it. But if you, for example, you want to reset to its original state, simply go to the top right, select the editor layout dropdown and click on default, and that is going to reset to the default editor layout here. Now, let's go over the main windows that Unity has to offer and how they're used in game development. So, the first one that you may notice is here in the center of our screen, we have the scene window. Now, the scene window essentially is a viewport into our game world. This is where we will be selecting on objects, designing our levels, constructing all the little bits and pieces for the objects in our game. Okay, you can see right now it is a sort of 3D environment, and if you're in a 2D game, it would look more like a 2D grid. Now, up next to where we have the Scene tab, you'll see there is another tab, and this one says Game. Now, if we click on that, it's going to switch over, sort of like a tab in a web browser. And this here is our game window. This is going to be what we see when we play our game, okay? And when we click on the play button at the top of the screen here, that is going to then play the game here in the game window. Now, I'm going to go back to Scene. We also have Asset Store, which we don't need to worry about at the moment. Next up, if we look over on the left-hand side, we have the hierarchy window. Now, this here is basically a list of all the game objects in our current scene. If we open up this little arrow next to sample scene here, we will see all of the different objects that are in our scene. Now, these are known as game objects, and a scene you can think of as a level, okay? If I select on one of these objects, like the main camera, for example, it will highlight it in blue. It will then select it here in the scene viewport. You can see we have the little movement gizmo here. And on the right hand side, the inspector window will be filled with a bunch of information that you can see here. Now, let's go over what happened. Essentially, when we click on a game object, it gets selected. We can see the selected object here in the scene view. And this here is our actual camera, which is rendering our vision for the game, essentially. So if we go over to the game window, this is what we are actually seeing through the camera. And then over in the inspector window, this here is essentially showing us all of the details and properties of the main camera. Okay, you can see here we have its position, rotation, scale, and then we have a bunch of camera settings like field of view. We can enable post-processing, a bunch of different things here, okay? Now, inside the inspector is essentially where we have a list of that game object's components. And components, we'll learn more about these a bit later on, but components are essentially the building blocks for a game object. Okay, transform gives it a position, rotation, and scale in 3D space. The camera component gives it the ability to render. And if we select on another game object here, for example, the directional light, this acts as our sun. You can see it gets highlighted in the scene view here. Over in the inspector, it has a transform component, which has its position, rotation, and scale, and then a light component, which we can define the color, the temperature, the intensity, all the different light properties here. And same thing for our final component, or our final game object, which is the global volume. And this essentially can add some post-processing effects like bloom and vignettes. Okay, so that is our hierarchy, scene, game, and inspector window. Now, in the next lesson, we are going to be looking at a couple other windows the editor has to offer, and then how we can actually play our game. So thanks for watching, and I'll see you all then. Welcome back, everyone. So let's continue with looking at some windows here in the Unity editor. So down at the bottom of the screen, you'll see we have the project and console. Now, the project window is essentially a bit of a file explorer, okay? Whenever we are creating a game, we'll want things such as 3D models, sound effects, textures. Those are all known as assets, and these assets get stored in our project files. The project window is essentially a look into our project files. You can see here we have folders and we have files here. Now, some files, when you select them, they'll have their properties displayed here in the inspector. And for folders, we can simply double click on those to open them up. So if I open up my scenes folder, you'll see we have a scene here that we can then double click to open up. On the left hand side, we can see a folder basically layout here. So it can be easy to jump between folders by just clicking on those. Or at the top here where we have the file path, we can simply click on a folder to return to it like so. Okay, so this is our project window where we'll be importing assets, we'll be creating new ones, so this is a very important window. And then finally, we have the console, which is a tab over here. And if we open up the console window, you'll see that there's not really much here. And that is because the console is here to basically display and log information. If there are any errors in our game or in our code, those errors will be displayed here. And also if there are any messages that the editor wants us to know about. For example, there might be an issue with importing something, or we ourselves can log messages. So in our coding, for example, if we wanted to test out a certain functionality, we could log a message to the console, and then that would be displayed here. Now, I personally like my console and project being displayed at all times. So what we can do is if I click and drag on a tab here on any particular window, I'm going to do that for the console. If I drag out, you can see I can kind of dock it anywhere I want. I can add it to the tabs here in my scene window. I could even add it down here and have its own little squished window. But I personally like to have it to the right of the project and left of the inspector here, okay, just so I can have more information on screen at once. But of course, feel free to experiment with whatever layout you wish. If we go to the top right to our layout selection, we can click default to return to our default, but there are also other ones. We can click on 4-split, which is going to change the editor into this layout. We have 2x3, which has this layout, which you may prefer as it has both the scene and the game view visible. But I'm going to switch back to default and then again get my console window out on the right hand side here. So this right here is a look at all of the default windows that Unity has to offer. Now, there are many more windows. There are dozens and dozens, maybe even 100 windows, but those are all for more specialized use cases such as animation or UI or audio. Okay, but these are the main windows that we'll be using throughout most of our game development journey. Now, how do we play our game? Well, to play our game, we simply want to go to the top of our screen and you'll see there are 3 buttons. We want to click on the first one, which is going to play our game. Now, it's going to have a little loading bar as the game needs to process, but then it will switch over to the game window, and this is where we will then play our game. At the moment, we don't have anything in our game, so we're not really going to have any functionality. But to stop playing the game, we can click on the play button again, and that will bring us back to our edit mode. Now, if we are playing our game and we want to pause for a second, well then we can simply click on the pause button here in the middle, and that is going to pause our game. If we then want to, for example, go frame by frame for our game, we can click on the step button here, which is going to sequentially increase frame by frame. Now, let's click on the play button again to stop playing, and that right there is a look at the play tools. Now, in the next lesson, we are going to be looking at how we can navigate around our scene here. Okay, there are many different navigational tools that we can use, so we'll be exploring those in the next lesson. Hey everyone, in this lesson, we are going to be looking at scene navigation. Now, over in the center, we have the scene viewport window. This is essentially a window into our game. This isn't where we play our game from. That happens over in the game window. The scene window is where we develop and build out our levels, for example. This is where we can place objects, move, rotate them, scale them. This is where we can see the visuals of our game and design the intricate bits of our level. Okay, now, since this is a 3D space, we will need a way of navigating around. So to start, I'm going to have my mouse hovered over the scene window and hold down the right mouse button. If I go ahead and drag, you'll see the cursor changes to this little eyeball, and I can basically look around as if it is a first-person camera. Now, while holding the right mouse button, I can then use the W, A, S, and D keys to fly around. Okay, so W to go forward, S to go back, A to go left, and D to go right. So we can already, you see, have a lot of freedom in where we are bringing this camera. Now, still holding the right mouse button, we can then press E to go up and Q to go down. So now we have these 6 buttons to basically translate ourselves around inside of 3D space. Okay, so we can go around like that, but what happens, for example, if we go very far away and we all of a sudden don't really know where we are? Well, for example, we can select a game object here in the hierarchy. Let's say I want to go to my directional light. Then I can press the F key on my keyboard, and that is going to bring the camera and focus it on that directional light. Same thing for the main camera. I can do it like so. Okay. So we have the ability to fly around. We can also use the scroll wheel to zoom in and out. We can then hold the middle mouse button, and this is going to pan our screen like so. Now, if you want to get a precise camera angle, for example, you might want a direct top-down angle, and it might be a bit hard to do it with the mouse. What we can do is look at the top right corner of the screen to this tool right here. This is our orientation gizmo, and it allows us to change the orientation of our camera. If I click on the green Y selection here, that is going to rotate my camera so I am now at a bird's eye view of our scene. For the red one, that's going to be along the x-axis, and the blue is going to do the same, but for the other direction. Now, I can also click on the center cube, and this is going to change the camera from a perspective view into an orthographic view, okay? Now, you may be wondering what's going on here. Well, essentially, a perspective view is where we have depth, okay? You can see the little squares here get smaller and smaller as they go off into the distance. This is essentially how we see things in the real world. But an orthographic view, you can see that if we zoom all the way out, these little squares are all the same size, okay? And that is because an orthographic camera doesn't have depth, okay? Something that is 1 meter away and 1 kilometer away are going to be the exact same size. And this is really good for if you have 2D games or if you want more precision with designing your levels. Now, if I go into a top-down view, it's almost as if the game is 2D, okay? And this is where we can basically lay out and position things with a lot more precision. But I'm going to go back to our perspective view right here. And yeah, that is a few of the different tools that we can use for scene navigation. So again, we can hold the right mouse button to look around. While looking around, we can use W, A, S, D, and Q, and E to fly. We can use the scroll wheel to zoom in and out, and we can hold the middle mouse button to pan. With a game object selected, we can then also press F to focus in on it. And also something else is that we don't have to select game objects by clicking on them in the hierarchy. We can select objects by simply clicking on their icons here in the scene view, okay? Just like that. Now, in the next lesson, we are going to be looking at game objects. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at game objects inside of Unity. So game objects are essentially the fundamental building blocks of our games. These are the entities that make up everything from our lights to our camera to our player to our 3D models of rocks and trees, the environment and everything that is interactable or visible in our game world. Okay, so that's quite an abstract look at what a game object is. Let's now look at how they actually work inside the engine. So when we created our project, we first of all had our sample scene here created. Now, if we go down to the project window, you can see we have our scenes folder, and inside of here, we have our sample scene. This is essentially the starting level that we load into, and a good way of thinking about scenes is like that. They are essentially levels. And inside of a scene, they are constructed with game objects. So these will be, like I said, our camera, our player, our 3D models, our different building blocks for our game. So over here inside the hierarchy, you'll see we have 3 objects inside of our scene: our main camera, directional light, and global volume. These are all game objects, and if we click on one, you'll see it is going to be highlighted. Here in the scene view, the game object will be selected, and then in the inspector, the properties of that game object will be displayed. Now, a game object in of itself isn't really much. The way we differentiate one game object from another is its components, okay? Now you'll see, if I select on the 3 different game objects here, you'll see they have different components. The main camera has a transform component and a camera component. The directional light, that too has a transform and a light component. And the global volume has a transform and a volume component. Now, components are essentially things we can attach to game objects in order to give them functionality. You'll notice that each of these 3 game objects have a transform component, which essentially gives that object a position, rotation, and scale in 3D space. Every game object is going to have a transform component, as this, like I said, gives it a existence, you could say, in 3D space. But other components, such as camera, will make this game object render whatever it sees. The directional light has a light component, which will basically shine light in a certain direction. In this case, the directional light acts as a sun. And the global volume is for post-processing effects. So how can we go ahead and create a game object? Well, the simplest way is inside of the hierarchy here, we can click on the plus icon, and this is essentially a big list of all the different types of game objects we can create. You can see if I go to 3D objects, we could create, for example, a cube. So let's create a cube right here. You'll see it is going to create the cube and add it to the hierarchy list here. I can then select it, and you'll see in the scene view that we have the cube here. Now, if I press F, that is going to zoom in on the cube, and we can then use our scene navigation tools to basically look around it. So this right here is our cube. Now, what components make up the cube? Well, if we go over to the inspector, you'll see it of course has a transform component, and here the position, rotation, and scale properties are basically determining where in 3D space this cube is positioned, its current rotation in degrees, and its scale, okay, or its size. We then have a mesh filter component, and this determines the mesh or the 3D model that is used for this cube. Now, if I click on the little circle here next to the cube mesh property, it is going to open up a window where we can select a different primitive mesh. If I select sphere, for example, you'll see here in the scene view that the model has changed to a sphere. So that is how we can change the properties of a component, okay? All these things inside of a component are known as properties. Then down here, we have the mesh renderer. This essentially gets that mesh and it renders it to screen using a material, which is something we'll be going over later in the course. And then finally, we have a box collider. A box collider is what we use if we want to start detecting collisions with objects and implementing physics, okay? It gives this box a physical shape. Now, we could also go ahead and create another game object right here called an empty. An empty game object is essentially going to be a game object that has no components apart from transform. So this pretty much only exists as an abstract point in 3D space. Now, with all game objects, at the bottom of the components, there will be an Add Component button. We can click on this and it is going to open up a list of all the different components that we can add. We have a little search bar up here, or we can search by the component category, okay? So for example, if I wanted to have a game object that emits a sound, I could go audio, and then you'll see there is a bunch of different audio related components. I could go down to audio source, and this component here can manage plain audio sound effects. So you can see there are a wide range of components, okay? So once again, a game object is essentially an entity, And on that game object, we can attach components to give it specific use cases, okay? For example, with a player, you might have a character controller component, which manages the movement of the player. You might have a collider on that player so that it can bump into surfaces. And then you might also have an audio component, which will then emit sounds whenever the player does stuff, okay? So there are many, many different types of components and different types of game objects that you'll create on your game development journey. Now, to delete a game object, we can select it. And once it is selected, we can simply press the delete key on our keyboard, and that is going to delete that game object. Also, let's select the cube right here. And in the inspector, you'll see that down here in Box Collider, we have a bunch of different properties. Now, these properties can be modified. So for example, if we want to change the size of this Box Collider, we can simply modify the size property here with the X, Y, and Z size. So for example, if I enter in a 2 for the X, a 2 for the Y, and a 2 for the Z, you'll see that my Box Collider is now basically twice as big. And we can modify these in different ways. You'll see if I hover over X here, I have this little arrow pop up. If I click and drag, that is going to allow me to quickly change the size. Same thing up here in the transform component. If I click and drag, for example, on one of the rotation axes, I can rotate it like so. Or I could manually go in and enter a value. So feel free to experiment with game objects. You might want to add some to your scene, modify their properties a bit to see what they do. And in the next lesson, we are going to be looking at using some tools to actually begin modifying these game objects in our scene view. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at how we can move game objects inside of Unity. So first of all, it's important to know that Unity uses an X, Y, Z coordinate system. Okay, now XYZ coordinate system essentially means that you need 3 numbers to pinpoint a game object's position in 3D space. Okay, you can think of a 2D graph, for example, where you have the X and Y axis, okay? Now simply chuck on another axis for depth, and there you have a 3D space. So now let's hop into Unity and look at how we can begin modifying that. So here in Unity, I'm going to go ahead and create a brand new cube game object. Now, before we looked at clicking on the plus icon here in the hierarchy and going 3D object cube, but another way of doing this is simply right-clicking in the hierarchy, then going down to 3D object cube. Okay, that's just a bit of a simpler way to do that. Okay, so that's going to create a cube right here. I can press F to focus in on it, and here we go. Now, if we look over in the inspector to the transform component, you'll see here we have our position property. Now the position property, again, just like our 3D coordinate system, it has an X, a Y, and a Z value. Now you can see right now X is set to -3 point something something, Y is 0, and the Z is 7.819. What I'm going to do is set these all to be 0, and you'll see the cube in the scene view is moving. Now this cube has moved over to the center of our scene here. And the center of our scene is going to be at 0 on the X, 0 on the Y, and 0 on the Z. This is going to be the dead center of our scene. If, for example, I want to set the X to be 1, you can see it is going to move 1 unit this way. If I set it back to 0, it's going to reset here. I can then also set it to be -1, and it's going to move in the opposite direction here. I can then go -5, and it will be over here. And I can also use Control Z to undo. Now, whenever I enter the number 1, for example, here, what does that mean? Is it 1 meter, 1 pixel? What is it? Well, in Unity, they use things known as units, or essentially meters. Okay, so when I enter 5 here on the X, that means that from the center to the cube, that is 5 meters. Okay, likewise, if I go 3 on the Y, this cube is now essentially 3 meters above the 0 coordinate here. Now, when we select the cube, and if we click off the cube and select it again, you'll notice that, first of all, there is this orange selection outline around whatever game object we have selected, and there is this thing that appears on top. This here is known as the Move Gizmo, and this right here is how we can move our object around the scene view without having to modify the position property in the inspector. Now, if you don't have this for some reason or it looks a bit different, we can go over here to our tool panel and click on the move tool right here, or the keyboard shortcut W. So with the move tool, you'll see we have 3 colored arrows. We have a green arrow, and this here represents the Y-axis. We have a red arrow, which represents the X-axis, and a blue arrow, which represents the Z-axis. In Unity, the X, Y, and Z axes are all represented by these distinct colors. Red for X, green for Y, and blue for Z. Now, if I go ahead and click and drag on one of these arrows, you'll see that I can move the cube along this axis. And if we look in the inspector, you'll see I'm modifying the X-axis. Okay, so we can click and drag to move that cube around like so. Likewise, we can click and drag on the blue to modify the Z position, and then on the green to modify the Y position. So with these arrows, we can sort of, as you can see, move and position our cube in 3D space, which is pretty cool. This is going to be especially great for level design. Whenever we want to place objects around our level, that's going to be perfect. Likewise, you may also notice that there are these little squares in the center of the move tool, okay? These 3 little colored squares. Now, if I click and drag on the bottom one, which is green, this is going to move our cube along the X and Z axis, ignoring the Y. So if you want to move something just along the ground, you can click and drag along that. We then have the blue one, which will move our object along the Y and X axis, and then the red one, which is going to move our object along the Y and Z axis. Okay, so with these things here, we can move our cube around pretty much wherever we wish. But at the end of the day, if you also want more precise movement, simply go to the transform and modify the position here directly. Now, when moving your cube around in 3D space, you might want to have grid-based snapping, okay? So you can see here we have this grid that is overlaid on our world, okay? And these are in 0.5 unit increments, or it may be different depending on your Unity setup. To change the grid size here, we can simply go to the top of our scene window, and you should have a little box here with a number called grid and snap. I'm going to set this to be 1, and now you can see the grid is going to be in units of 1. Now, to actually have our cube snap to the grid, what we can do is click on this button here with the little magnet icon, and that is going to toggle snapping. Now, when I click and drag my cube, you can see it is going to move in increments of 1. This can be great if you're trying to align something. Maybe you have a door that you want to align in a doorway and you want it to be precise. You can enable grid snapping for that. Now, if we click on the little arrow next to the grid snapping, we can actually change the grid size. Okay, so we might want to snap to grid, and then in the future lessons, when we look at rotation and scaling, you can also snap those values as well. So that is a quick look at moving game objects around in 3D space here in Unity. Again, we have the move tool, which you can enable by clicking on it here in the left-hand side panel, or by using the W keyboard shortcut. Then you can click and drag on these arrows. Oh, I'm just going to disable move grid snapping here. You can click and drag on these arrows to then move it around. You can click and drag on these squares to move them around specific axes, like so, along specific planes, you might say. Or in the inspector, under the transform component, we can modify our position property here on the X, Y, and Z axis. So there we go. That is how we can move around objects inside of Unity. In the next lesson, we are going to be looking at how we can begin to modify the rotation of objects. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at using the rotation tool inside of Unity. Like with moving, this is going to allow us to change the angle and orientation of our selected game object. So I'm going to go ahead and create a brand new cube by clicking on the plus icon here and then going 3D object, cube. Now, with this cube, by default, it is going to have the move tool selected. So to switch over to the rotate tool, we can go over here to our tool panel and click on the rotate tool like so, with the keyboard shortcut of E, okay? So now with the rotate tool, you may notice that it looks kind of similar to the move tool. We do have the specific colors of red, green, and blue, which represent each of our different axes. If we click and drag on green, for example, this is going to rotate the cube along the y-axis. And if we look over in the inspector, you can see the property for y is changing. Now, this number is not in terms of meters or pixels, but rather in terms of degrees. So you'll see if I rotate it about this, it is going to be around 90 degrees, okay? And yeah, so position is in terms of meters and rotation is in terms of degrees. Likewise, we can click and drag on the red circle to rotate along the x-axis and the blue to rotate along the z-axis. Now, you may also notice there is a circle around the rotate gizmo, and this here, if we click and drag, rotates the object relative to our current view perspective. So if I move the camera to be sort of top down almost, you'll see it rotates it roughly top down. Or if we just click and drag anywhere within the sphere and drag, it is going to rotate basically freely, okay? So if you want a random rotation for something, you can easily just click and drag, and that will give you a nice rotation like so. Okay. Or we could just go into the inspector and manually set our rotation. So for the X, we might want to go 45. For the Y, we might want to go 8. And for the Z, we might want to go -25. And there we go. We can set our rotation like so. I'm just going to reset it back to 0. And next up, we are going to be looking at another feature that Unity has to offer. So to start, let's just go ahead and rotate our cube a little bit, like so. And then what I'm going to do is I'm going to press W to go to my Move tool. Now, by default, you should notice that the Move tool has rotated itself, okay? The green arrow is no longer pointing up, it's pointing up relative to the cube's rotation, okay? So if I rotate the cube again, let's say I rotate the cube a bit more over like so, and then press W, you'll see that the green arrow is now pointing horizontally. This is because, by default, the Move tool is going to be orientated based on the cube's local rotation. Now, this might be useful. For example, you might have a tree, for example, that you want to align along a mountainside, and this could be good for then aligning it along at an angle. But you might want the Move tool to still be relative to global space, okay, or global coordinates. And to do that, we can go to the top left corner of our scene window, and you'll see here we have a button that says local. If I click on that, you'll see I can choose between local and global. If I select global, that is going to change the Move tool. So now, no matter what rotation I give the cube, it is always going to be pointing in terms of local coordinates, okay? Y is up, Z is forward, and X is right. But if we switch that back to local, you'll see that it will change the orientation of the tool to point in the cube's local rotation, okay? Same thing with the rotation tool. If I press E to go to the rotate tool, you'll see that the lines here are relative to the cube's current rotation, but if I switch that over to global, it is going to switch it to a global tool here. So if we want to rotate it along the global y-axis, we can still do that. Or if we want to rotate it along the local y-axis, we can do that here as well. Now, something that is important to note is if we go over into the inspector and we modify the Y position here, that is always going to move it based on the global position here, okay? So if we modify Y, that's going to be the global Y direction, not the local Y direction, okay? Whereas with the tools here, we can choose to be global or local. So there we go. That is a look at the rotate tool inside of Unity, as well as local and global rotation here and positioning. Now, in the next lesson, we are going to look at our final tool, which is going to be scaling. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at the scaling tool inside of Unity. So what I'm going to do is start by creating a brand new cube. So I'm just going to right click, go 3D object, and create a cube right here. I'm then going to press R, which is going to switch me over to the scale tool, or we can go over on the left hand side to our tool panel and select the scale tool here. Now with the scale tool, you'll see it looks very similar to the Move tool, which has the arrows, but the scaling tool has these little cubes. And this right here allows us to change the size of the game object along a certain axis. So for example, if I click and drag along the Z blue axis here, it is going to scale it like so. And if we look over in the inspector, you can see that our scale is now 1 on the X, 1 on the Y, and around 3.5 on the Z. I can then do the same for the X and for the Y here as well. Okay, I'm just going to undo those back to normal, and there we go. Now, you'll notice that the default scale, unlike rotation and position, is not 0, it is 1. And that is because scale is not really a distinct value or measurement. Rather, scale, you could think of it as a multiplier, okay? With a scale of 1, the object is 1 times its original size. If we then go into the scale and set it to be 2 on each axis here, that is going to make the size of the object twice as large. We can then set that to be 5, and it is going to be 5 times as large. But if I set it to be 0.5, it is going to be half the size of the original game object. So scaling works like that. We can also click and drag on the central cube here to scale uniformly along all axes. Now, just like with our move and rotate, if I go ahead and rotate this cube and then press R, you'll see that based on our local or global space definition here, we can then change the orientation of the scaling. But if I switch between local and global, you'll notice that the scaling tool does not switch back to global scale, okay? So if I set it here to be global and go to my move tool, you can see the tool is orientated to the global coordinates, same with rotation, but not with scaling. And that is because scaling inside of Unity is specifically along axes of that game object. So a global scale would not really be possible. So that's just important to know. Okay, now, between now and the next lesson, I want you to go ahead and complete this challenge. I want you, using the move, rotate, and scale tools, to create a stick figure like the one you see on screen. Okay, so legs, a body, arms, and a head. Use different 3D objects as well. Remember, when we create the cube, there is that list of other objects, such as spheres and cylinders. Go ahead, experiment with whatever sort of objects that you want and what ones feel right. This is a bit of an open form challenge, but do try and create a stick figure that looks similar to the one we see here. So have a go at that, and in the next lesson, I'll see how you're done and we'll go through the solution. Okay, so I hope you had a go at the challenge. Let's now hop over into Unity and have a look at the solution. So here inside of Unity, what I'm going to do is first of all create the body. So I'm going to right click in the hierarchy, go 3D object, cube. I'm then going to switch over to my scaling tool by pressing R. And then I'm going to shrink the torso so it's a bit thinner here, and then bring it up a little bit like so. Then for the legs, what I can do is duplicate this object, or I could go ahead and create a new one by going Control D. That's going to duplicate the game object. You can see it has now created a new game object, basically of the exact same type, and changed the name to have a 1 at the end. If you do want to change the name of game object, simply go over to the inspector and you can change the name here. So I might call this one leg, for example. Then what I'm going to do is go to my move tool. I'm going to bring this leg down to the bottom right. I'm then going to press E for the rotate tool and just rotate it like so. Maybe I'll scale it down a little bit as well. I'll position it here, and then I'll go Control D again, and I'll rotate it the opposite direction. Now, if you want scaling to be, or rotating to be precise, you can hold down Control, and this is going to snap our scaling like so. And we can change how large the snap is in terms of degrees by going to the top right corner here, and go into our snapping settings and changing the rotate snap. So if I change that to 5, now our rotate increments are going to be much smaller, but I'm going to keep it at the default 15. Okay, there we go. I'll move this leg over here. And then what I'm going to do is I'm going to create the arms. So I'm going to select the cube that we used for the body. In fact, I'm going to rename this one to be body. Then I'm going to duplicate it. I'm going to rotate it 90 degrees, so it's a bit horizontal. I'm then going to scale it down a little bit and stretch the arms out like so. I'll then move it up, and I'm going to call this one arms. And then finally, we need a head, and we're going to use a sphere for this. So if I right click in the hierarchy, go 3D object, sphere, I can then rename this one to be head. and then I want to bring it over here and move it up like so. Make sure it's in the right position. It's a bit small, so let's press R for the scale tool and scale it up. And there we go. We have gone ahead and created ourselves a stick figure. Now, something else we might want to do is align it properly. So what we can do is select all of these game objects by clicking and dragging, and that is going to select the game objects like so. Alternatively, we can click on a game object in the hierarchy and then hold down Control to select all the ones we want, or we can click on one game object, press Shift on the last, and that will select all of them in between, okay? Very similar to how it is in other programs. We can then go and position it wherever we wish, and you'll see if we use the Move tool, it is going to move all of those. If we use the Rotate tool, it is going to rotate all of those. It does look a bit strange, but then also if we use a Scaling tool, it will scale them as well. But let's just move this into a nice position, maybe somewhere over here, and there we go. So there is our stick figure. Welcome back everyone. In this lesson, we are going to be looking at the concept of object parenting inside of Unity. So there are two concepts we need to understand. That is the parent and the child game object. Essentially, what we can do is have a game object have children game objects. These children game objects will inherit the position, rotation, and scale of their parent object. So let's look at how this works in practice. I'm going to right click on the hierarchy here, go create 3D object, and I'm going to create, let's just say, a capsule. And I'm going to call this one our player. Now, with our player object here, let's say we want to give them an item to hold, for example. So we can go ahead, create a cube here. We can call this cube an item. And then we might want to scale it down, and let's position it in front of the player here to look as if they are holding it, okay, or something like that. Now, let's say we then want to move our player around. Well, we'd select our player, and then we'd move them around. But we want the item to follow along with the player. So how do we do that? Well, we could move the item and the player at the same time. We could move the player, then move the item, but this can be quite laborious if there are a lot of things that we want to track to the player or track to another object. So this is where parenting comes into play. Now, what I'm going to do is I'm going to select the item here, and in the hierarchy, I'm going to drag the item game object on top of the player and let go. This right here is going to add it as a child to the player. And you'll see that the child object is now indented a little bit, and the player here has a little drop down that we can toggle open and closed. So now the item is a child object of the player, and the player is the item's parent. So now look what happens if I move the player around. If I move the player around, the item follows as well. That is because, like I said, all of the transform properties, the position, rotation, and scale of the parent get applied to the child. So if I select the parent again and, for example, rotate it, you'll see that that item game object is also rotating along with us, which is very nice. Same thing for scaling as well. But you will notice that if I go into my item here and move that around, that does not modify the parent's position, okay? It's a one-way street. The parent affects the children, but the children don't affect the parent. But if we were to have a child of the child object, then we can create a sort of tree-based hierarchy that way. So if I were to then duplicate the item with Control D, maybe scale this one down a little bit and move it out here, and then make that a child of the item, you can see now we have this sort of 3 deep structure. If I move the player, all of these items will move. If I move the first item, child, that is going to move item and item 1. And then if I move item 1, that is just going to move itself. So that is the concept behind a parent and child relation inside of Unity. And you'll be using this for a wide range of uses. For example, with a player. The player might be holding an item, they might have armor on, they might have an audio game object that emits sound that you want to track along with them, they might have particle effects for running, so many things, and parenting and using children inside of Unity will become second nature to you, as it really is a core part of the engine and utilizing game objects. Okay, now as a bit of a challenge, I want you to go ahead and create this sword right here using 3 separate cubes. Position them, rotate them, scale them, and then set up some parenting so that we can move just one of them to affect all the others. So have a go at that, and I'll see you how you're done in the next lesson. Okay, so I hope you had a go at that challenge. Let's now hop over into Unity and have a look at how we can set this up. So first of all, let's go ahead and create our sword. So what we can do is create a brand new 3D cube. I am then going to make this one the hilt, so we might want to, first of all, I'm just going to position it in the center. So I'm going to go 0, 0, 0 for the position, and then we can work with it as it's going to be nice if it's nice and centered here. So I'm just going to scale this down to about the size of the hilt. There we go. We can then duplicate that, move it up, rotate it around, and then I'm going to scale this a bit more. There we go. And then finally for the blade, we can duplicate this one again. We're going to move it up, scale it to how we want it to look. Maybe make this a bit thinner. There we go. And as you can see, we have now gone ahead and created a basic little sword. So now what we want to do is make it so that this sword is going to act as one solid object. Now for this, we could basically select the hilt and then drag in the other 2 game objects as children. And then if I rotate this object, you'll see all the others follow in suit. Same with movement as well and with scaling. But what I'm going to do is I'm going to unparent all of these by simply dragging them out. If you have an object parented and you no longer want it to be a child, simply click on it and drag it out into the open, and that is going to detach it. What I'm going to do is create an empty game object, which is going to act as the parent object. And this is good because an empty game object can act as a container, and this is where we can define a pivot point for the object as well. So I'm going to right click, create empty, and I'm going to call this one sword. Now I'm going to set its position to be 0, 0, 0, so it is nice and centered, and then I'm going to drag all of these models in one by one to be a child of sword. Now we have the empty game object here that we can move around, rotate, and of course scale. Now, why might we want to do this? Well, you'll see right here the pivot point, or the origin of this game object, is down here in the middle of the handle. Well, let's say we want to change the origin to be in the middle of the blade, or 2/3 down in the blade. Typically, if we're doing that with just one of these objects, these kind of have fixed pivot points. But what we can do is click on these, drag them down, and now you'll see that the parent object has changed its pivot point. So using an empty game object is great, as it allows you to change basically the relative position of all the objects that are a child of it. So there we go. That is how we can create a simple little sword using our cubes and object parenting. Now in the next lesson, we are going to be exploring materials to give our objects a bit of a nicer appearance. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be looking at materials inside of Unity. So what is a material? Well, essentially a material defines how an object is rendered to your screen. This material can define stuff such as the color of the object, the texture, the roughness, how metallic it is, and how it reacts to light, along with a bunch of other things. This is how we get distinct surfaces and textures in our game world. So now let's go over to Unity and look at how we can create those. So in Unity, materials are known as assets, and an asset is essentially a file we save to our computer that can be used inside of our game. Now, down here in my project window, you'll see I have some folders and some files that were created by default. These folders can contain what are known as assets. Okay, you can see here we have an asset which is of type script. Inside of scenes, we have our scene asset, which references this current scene here. And what we can do is create our own asset. So if I right click in the project window, go up to create, I can go down to where we have material. Now if I create that material, is going to create a new file here. I can then give it a name. I'm just going to call this one test material. And then you'll see the preview image has this sphere. Now, if I select the material and go over to the inspector, you'll see there is a large list of different properties. This is essentially the properties that we can modify to tweak the material to how we want it to look. So we have our material properties here, and down at the bottom we have this little preview window. We can click and drag on the top bar to change the size of it, and this here is going to show us essentially what our material looks like. Now, before we go in and begin modifying these things, let's go over how we can actually give a material to a game object. Now, materials can only be attached to 3D meshes, okay? So we can't attach a material to our camera or light, that's just not how they work. So I'm going to go ahead and create a brand new sphere object here in the hierarchy. Okay, let's focus in on that. And what you'll notice is that this sphere has this gray sort of color to it. And this is actually a material. This is the default material that is applied to every mesh inside of Unity, but we can of course change it. Now, to change the material, we simply want to select the object, and then inside the inspector, go down to the mesh renderer component. This determines what mesh is being rendered, as well as the material that is applied. So if we then open up the materials drop down here, you'll see we basically have a property here using the default lit material. Now, if I click on this little circle here next to the property field, it is going to open up a window where we can then select our material. Now, we can see here we have our test material, so we can select that right there. And what you'll notice is that the material has suddenly changed the visual look of our model. Now, another way of applying a material that may be a bit quicker is to simply drag and drop the material from the project window into the field here. Or alternatively, we can click and drag the material onto the game object itself in the scene view. Now, let's select our material down in the project window again and go to the inspector. Here you'll see we have a number of different properties, base map, as well as a little color field here, which is going to change the color of the material. So if I click on that, it's going to open up this little color picker where I can go ahead and change the color of the material. And you can see here how it changes that instantly. So we might make this red, for example. This base map here is where we can assign a texture. So if I click on this little circle next to base map, we can click to assign a texture to it like so. We don't have any textures in our game at the moment, so we can't really assign any of those. Down where it says metallic map, this changes how, I guess, metallic the material looks. So if we go ahead and modify that, you'll see at 1, it's 100% metal, and at 0, it is basically 0% metal. Likewise, we have smoothness, which can change how smooth an object appears. At 0, it's pretty much 100% rough with no reflections. But if I bump that up to 1, you'll see it is a now very reflective surface. And if I then bump up the metallic value, that is also going to make it look very metallic and very smooth. We have a few other properties that you can, of course, go ahead and experiment with. One more thing I do want to show you is how we can make an object translucent, because right now the object is opaque, meaning we cannot see through it. But if we go to where we have surface type and change that from opaque to transparent, now if I go down to my base map and open up the color picker, what I can do is go down to where we have the A slider, and this stands for the alpha value or the transparency. And if I adjust this, you'll see that my sphere can fade in and out. Okay, so that is how we can make a material translucent, for example. If you had glass or if you had some sort of gem that you wanted the player to see through, yet at the same time having its own color. So yeah, that is a quick look at materials inside of Unity. Now, as a bit of a challenge, I want you to go ahead and attempt to recreate the 3 materials as seen below. We have a red sphere, which is quite reflective. We have a rough blue sphere, and we then have a green translucent sphere. So have a go at recreating those inside of Unity, and I'll see how you've done in the next lesson where we'll go over the solution. Alright, so I hope you had a go at the challenge. Now let's hop over into Unity and look at the solution. So first of all, I'm going to go ahead and create my 3 spheres. So I'll go 3D object, sphere. Let's bring it down to 0 on the X, 0 on the Y, and 0 on the Z, just so it's centered in our scene. I'm then going to go Control D to duplicate the object, and then holding Control, I'm going to drag to snap on the grid, okay? We could go up and enable grid snapping here, but alternatively, you can simply hold down Control and do the same thing. So we'll have that one there, duplicate again, and then move it over to the right. Now let's start with our materials. So first of all, we have our reflective red sphere. So I'm going to create a new material here in my project browser, and I'm going to call this one red. I'm just going to call it red, okay? Then what we're going to do is click and drag it onto the first sphere here, and in the inspector, we can then set the base map color to be red. And then with the smoothness, I'm going to bump the smoothness all the way up to 1 so that we have a nice reflective sphere. You can see it reflecting the skybox around us. We don't need to mess with any of the other settings. Now for our rough blue sphere, what we're going to do is create a new material here. I'm going to call this one blue. I'm then going to drag it onto the central sphere. And then in the inspector, I'm going to set the base material to be a nice light blue color like so, and then bring the smoothness slider down to 0. So as you can see, there is absolutely 0 reflections on this model. Then finally, we have our green translucent sphere. For this, I'm going to create a new material. I'm going to call it green, and I'm going to drag it on like so. Then in the inspector, we want to go over to where we have surface type and change that from opaque to transparent. Then in the base map, we want to set this color to be green, and then the alpha value down here, I'm going to bring to be around halfway. Then I'm going to bring the smoothness all the way down to 0, and there we go. Now to prove this is truly translucent, we can simply move our camera, and we can actually see the blue sphere through it. So we know that is working there. Now, between now and the next lesson, I want you to go ahead and just start experimenting again with these materials. Try and create different types, try and add different colors, smoothness, combinations, maybe even try and experiment with some of the other settings here. Feel free to enable things, modify their values, maybe even apply a texture by clicking on the little circle here next to base map. You can even drag in a file and stuff like that. And one final thing I'm going to do is I'm going to get all 3 materials we have here in the project browser and put them inside of a folder. So to create a new folder, we simply want to right click, then go create folder. I'm going to call this one materials. And then simply we can click and drag the assets into the folder, and that will move them like so. Now, if we go inside of our materials folder by double clicking on it, we can see we have our 3 materials right here. If you want to go back to the root folder, simply go up to the top and select assets. So there we go. That is a look at materials inside of Unity. And in the next lesson, we'll be exploring prefabs. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be looking at prefabs inside of Unity. Now a prefab is essentially a game object that we can save to our project window. So essentially this prefab is an asset, and with this prefab we can create instances of it in our scene. So what I'm going to do is go ahead and create a brand new 3D object. Let's go ahead and create a cylinder this time. And let's just say this is our tree. Now, to make it look more like a tree, I'm going to go ahead and create another 3D object. Let's create a sphere. I'm going to center both these objects. So I'll set their positions at 0, 0, 0, just so they're a bit easier to work with. Okay. And with this sphere, I'm simply going to drag it up and increase the scale. So we have this nice little tree right here. I'm then going to go ahead and create some materials for it. So I'm going to create a material here. I'm going to call bark, which I can then drag onto my cylinder, and I can set the color here to then be a brown, something like that. And then I can create another material for my leaves. Drag that onto the sphere and make this the color green. So there we go. Now I'm going to go ahead and rename the cylinder to be, I'll call it tree trunk, and the sphere to be leaves. I'm then going to go ahead and create an empty game object called tree. I'm going to set its position to be 0, 0, 0, and then add the leaves and the trunk as a child. So now you can see I can modify the rotation, position of this tree, and it remains the same. Now let's just say in our game we want to have many trees. Well, what we could then do is duplicate the tree game object and move it around. So now you can see we have multiple different trees. But what happens if, for example, we say, okay, I want to go ahead and actually change the size of my leaves. So I'll go to this game object here. Let's say we want to scale those leaves up. I'll then have to go to this one, scale those ones up, go to this one, scale that up. And you can see how this can be an issue. If we have hundreds or thousands of trees in our level and we want to change something about all of them, we would have to go one by one through each object. So what we can do instead is turn this tree into a prefab, okay? And I'll show you how we can do that. So first of all, I'm just going to delete all of these trees that we're not using with the delete key. And then with the tree that we want to save as a prefab, I'm going to select it and drag it into the project window. Now, what will happen is you'll see we'll have this new asset created called tree, and it has a little preview window of what it looks like. Also, in the hierarchy, you'll see that our tree game object is now blue. It has a blue icon with a blue name and blue children. This is to basically tell us that this is a game object that is referencing a prefab. So now if I go ahead and make a copy of the tree, let's add a few trees in here. What happens if I want to change the leaves? Well, I could go ahead, just like before, and change the scale of the leaves here one by one, or what I can do is edit the original prefab, okay? Because a way of thinking about prefabs is like a blueprint. The prefab is the blueprint, and the game objects that we create in the scene are the instances of that blueprint. Whenever we modify a property of the prefab or blueprint, that changes the instance object. So, to edit a prefab, we can simply go to it in our project browser and double click on it. This is going to open up the prefab editor. On the left-hand side, you'll see the hierarchy now basically lists only the game objects within the prefab. You can see up here, it says tree, so we know that we're editing the tree prefab. And here in the scene view, we have our tree. Now, what I'm going to do is simply select the leaves and increase them in size. In fact, what I might also do is, instead of that, I might move them down a little bit, duplicate that leaf, bring it up, and then scale that down, okay? So now we have a nicer looking tree, because later on we might want to change the model or change something about the tree, and instead of doing it one by one, we simply edit the prefab. We can then save with Control S, or by going up to File, Save. Then we're going to go up to the top left of the hierarchy and click on this back arrow. That is going to return us to our main scene, and what you'll notice is that all of the instances of that tree prefab have been updated with the change, which is pretty good. Now, something also to note is that if I go ahead and modify something on one of these instance prefabs, let's just say I select this one here and I go inside and I edit its leaves, maybe I want these leaves to be smaller, you'll see that this does not get applied to everything else. And that is because if we edit the instance, that only changes that game object's properties. If we modify the prefab file, which is the blueprint, that modifies every instance that is created from it. Okay, so that's important to know. You can still make individual changes on the individual prefabs, but changing the prefab file itself changes everything. So yeah, that is a look at prefabs inside of Unity, and there are many, many use cases where this can come in handy. For example, if you have, like I said, environments like trees or rocks or grass that you want duplicated hundreds or thousands of times, prefabs are great. If you have an enemy that you want to fight the player and you want to have many of them on screen, you would use a prefab and you would spawn in that prefab to then attack the player. Likewise, if you have a gun that shoots bullets, each of those bullets will be a prefab with its own collision detection logic that you could then modify to change all the bullets and their behaviors. Okay, prefabs are a very powerful tool and definitely something that you'll be utilizing in your Unity journey. Hey everyone, in this lesson we are going to be exploring lighting inside of Unity. Now lighting is a very important part of game development as it allows us to tweak and design the visual look of our games. Now I've gone ahead and created a little simple test environment here with a ground plane game object with a grey texture, as well as these cubes with a white material applied. So, one thing you may notice is that there is already light in this scene. We have essentially a sun beaming down onto our scene here. You can see one side of the cube is brighter than the other, and it is also casting a shadow. Now, this light is being controlled by our directional light game object. We can see it here inside of the hierarchy, and also in the scene view, we can see its icon here. Now, if we click either the object in the hierarchy or in the scene view, that is going to select it. And you'll see on the object itself, it has these rays that are pointing out from the center, and this essentially shows us the direction of this light. And if we go to the inspector, you'll see that this game object has a light component. Now in Unity, there are many different types of lights. The most common one you'll be using is going to be a directional light. You can see here under type, it is set to directional. This essentially acts as a sun, where the light comes in all from one direction. Now, we can of course modify these properties. First of all, we can change the angle of the sun by pressing E to go to our rotate tool. And if I rotate the sun or the directional light, look what happens. Our scene gets darker and the shadows get stretched out. This is here to basically simulate the sun inside of our environment. So if I flip it all the way around, it's essentially nighttime. Now we can modify things a bit more precisely. If we go to the inspector and down to where we have color, we can change, for example, the color of the light. Right now it is set to a very, very light yellow, sort of to simulate sunlight, but I can change it to be green, for example, or I could make it blue, purple, or red. I can make it pretty much whatever color I want. We can also go ahead and change the intensity. This number here defines how strong the light is. You can see the higher I make this value, the stronger the light appears, but by default it is going to be set to 1. Now, lighting in of itself is a very in-depth pillar of game development, so there is a lot more stuff when it comes to lighting, but we're only going to be looking at the basics here. If you want to change the shadows, you can go down to where we have the shadows type and change that from soft to no shadows. And this can be good for performance, okay? Shadows is generally something that is quite performance impactful, so generally have limited number of lights that emit shadows, as that will help on performance. But you'll see there are 3 different types of shadows we can select: no shadows, hard shadows, and soft shadows. So what are the difference between hard and soft? Well, if we go soft shadows, you can see the edge of the shadows here have this nice blur. If I set it to be hard shadows, you can see that the shadows have a more jagged edge. This is going to be better in terms of performance, but again, the shadows do look a bit jagged around the edges, so I'm going to switch it back to soft. Now, we don't just have the directional light, we have many other light types as well. What I'm going to do is right-click in the hierarchy and go light, and then you'll see here we can create a directional light, which is the one we already have, a point light, which is sort of what you would use for a candle or a light you want to emit in all directions, a spotlight, which you would use for car headlights or a street lamp, and then some other lighting game objects, which are a bit more complex. So I'm going to go ahead and create a point light, and this is going to create a new game object here in our scene. Now, if I move it around, you may notice that the light can appear on the surfaces here, and it also has this white circle around the outside. This is the range of the light. So if I, for example, turn off my directional light so we can see the point one a bit better, to turn off a game object, we simply select it. And then in the inspector, up next to where we can change the name, there's a little checkbox. I can simply uncheck that, and that is going to disable the game object. You'll see here in the hierarchy that the disabled game object is now grayed out to show us that it is no longer active. So if I select my point light, you can see its effect a bit better. I'm just going to up the intensity a little bit as well. So I'm going to set the intensity here to be 10. Now you can see the light affecting things a bit more. So I can move it around. I'm also going to change the color to be red so we can see it a bit better. And this circle, or the sphere around the point light, is its range. This determines the furthest most point that the light can reach. So if I bump this light up to an intensity of maybe 100 or 1000, you can see it is never going to exceed past the length of this sphere. Okay. Other things, we also might want to enable shadows. So we can go down to shadow type and set that to soft shadows, and that will enable shadows. So you can see now how if I move the light around, it is actually going to begin affecting the objects around it, which is pretty cool. So you can see how you can add lighting to really change the mood of your game. Now, that right there is a point light. Next, let's look at a spotlight. So I'm going to right click in the hierarchy, go down to light, and then go down to spotlight. And this right here, as you can see, is a light that emits in a cone. So if I move it up here, so we can see it a bit better, it may be a bit hard to see because the intensity is too low, so I'm going to change the intensity here to be about 30, and there we go. We can now see this spotlight basically shining down on the ground. I'm going to change its color to be green so we can see it a bit better, and I'll up the intensity again. So let's maybe make an intensity of 100, just so it's a bit easier to see. So this can be great for headlights or a spotlight down from a lamppost. This essentially just shines light in one specific direction. Now we can change the angle two ways. We can either affect it here in the scene view by clicking and dragging on these little nodes to change the outer and inner angle, or we can go to the inspector and change the shape inner/outer spot angle here with this slider and adjusting it with these little modules on the edge. So there really is quite a lot of customization when it comes to lighting inside of Unity. And again, we can go down to shadows and enable those as well to get shadows. So yeah, that is some lighting inside of Unity. Again, we have the directional light, which I'm going to re-enable by enabling it here in the inspector. This can act as a sun, or at nighttime it could act as a moon. We then have our point light, which emits light in all directions. And like with the spotlight, you can also click and drag on the edge of the sphere here to change its range if you wish. And then we have the spotlight, which emits in a cone, and we can modify that as well. And also, if we click and drag on the central node, that is going to change the range of the spotlight. So there we go. That is a look at the 3 different types of lights inside of Unity. Feel free to experiment with them, as there are many different things you can do with lighting to change the overall feel of your games. Hey everyone, in this lesson we are going to be going over physics inside of Unity. Physics allows us to have objects that can fall, with gravity that can interact with other colliders, things such as crates you might want the player to be able to push around, a ball you might want them to kick and have fly from the distance, or bullets that you might want to fall to the ground over time. Maybe even a player controller that can bump into walls, go up slopes, and be affected by other things. This is going to require Unity's physics system. So I've gone ahead and created a scene here where I have a plain floor here and a sphere as our ball. And what I want to do is make this ball fall down and hit the ground. Now, I've also gone ahead and positioned my camera so that it is facing the ball. So if I go over to my game window over here, you can see I have this view. Now, if I go ahead and press play at the top of the screen, this is going to essentially launch my game, and then we can see it essentially running in the game window. But as you can see, nothing happens, and that is because all of these objects don't really do anything at the moment. So what I'm going to do is, if I go back to my scene view here, I'm going to select the ball, and then I'm going to go to the inspector, go down to where we have the add component button, and I'm going to add a new component. Now, we could search for it here in the search bar, or if we go down to the physics category, we'll select that. And this is all of the different physics objects that we can add to our object. Now, if we want this object to be able to be affected by gravity and hit other objects, we want to add the rigid body component. So I'm going to add a rigid body component here. You can see there are some properties we can modify, but I'm not going to touch anything just yet. And then I'm going to press play again, and let's see what happens. And as you can see, the ball is going to fall and hit the ground. Now, when we are playing our Unity game, we can still actually edit the game. So if I go back into my scene view, I can actually select the sphere, and then if I go to the inspector and change its position to maybe 5, you can see the ball is going to change, and then it's going to fall back down again. So we can sort of experiment with that here. But one thing you'll notice is that when I press the play button again to stop playing the game, it is going to reset everything, all the modifications that we made during the gameplay to its original state, okay, from before we clicked play. So if during the game you modify a few game objects, whenever you stop playing the game, it will reset back to its normal state. So now that we have gravity being applied, we can have a look at some of the other settings. So if we go to the inspector and scroll down to the rigid body, you'll see here we have a number of different things, such as mass, which determines how heavy the object is, linear damping, which can apply wind resistance, angular damping, which does the same thing for rotations. We can then enable whether or not this object uses gravity. If you're having a game set in space, you might not want to have gravity. And then we have a couple more advanced things here. So as you can see, we can create a ball and it can fall to the ground. But it's not just gravity, it can also then interact with colliders, okay? Because since this ground has a mesh collider component attached to it, that means it is going to act as essentially a solid surface. So what I could then do is if I go ahead and create a brand new 3D cube, and I'm going to give it the ground material. So if we go over to the mesh renderer component, down to materials, we can click on the little circle here and select the ground material right here. Okay, so what I'm going to do is I'm essentially going to move this cube over here, and I'm going to create a sort of ramp. So if I just increase the size of this like so, I might then want to give it a bit of a rotation. So we have a bit of a ramp here. Now we have a bit of a ramp, which is cool. And if I go back to my game view, this is what it's going to look like. So what do you think is going to happen when I press play? Well, if I go ahead and press play, what you'll notice is that the ball is going to fall down, and it is going to roll along the surface. And then since this is basically open air, it is just going to fall all the way down, okay? So you can see how you can easily add physics into your game with just one single component. And we can of course go ahead and add as many of these balls as we wish. So if we want to have a bunch of different balls here, essentially interacting with the physics system, we can go ahead and do that, duplicate all of these. And then if I go ahead and press play, we should see it essentially raining with these rolling balls that go down the ramp and off the edge. So that right there is a quick look at Unity's physics system, using the rigid body component to give physics to a game object. Thanks for watching. Hey everyone, in this lesson we are going to have an introductory look at scripting inside of Unity. So what is scripting? Well, essentially scripting is how we can create the gameplay behaviors and logic for our game. This is also known as coding or programming. This is where we write down the code to make things happen. Now, a script is essentially a file that we can create, and think of this like a text document, okay? This is a file that contains all of our code, and then what we do with that script file is we can attach it to a game object as a component, okay? Because scripts are essentially components. All the components we have looked at so far, like the light, the camera, the rigid body, in essence, these are also scripts. Behind the scenes, they are just code that is running to give that game object a specific functionality. And we can create our own custom components this way with scripting. So let's hop over into Unity and look at how we can set that up. Okay, so here in Unity, to create a script, we're going to go down to our project window and right click. Then we're going to go up to create and down to where we have mono behavior script. Okay, so we're going to create that here, and we can then give the script a name. I'm just going to call this my first script and hit enter. And there we go. We have now successfully gone ahead and created a script. Now, when it comes to programming, you may have heard the term coding language or programming language before. This is essentially the language or the way that we write code. And just like in real life, where you have different languages like English, Spanish, Japanese, there are also many different coding languages. And in Unity, we use the C# coding language. You can see on the script file here, we have the pound or hashtag symbol for C#. Now, to open a script, we simply want to double click on it, and this will open up Visual Studio. Now, your Visual Studio may look a bit different to mine. That is just because I've changed some of the theming here. But overall, the program should be very similar in the sense that we have some text displayed on screen. Okay, on the surface it may seem very similar to Word. We can write down text, we can backspace. It's basically a text editor. But what makes Visual Studio so special is it is a program specifically designed for writing code. Now, why is this any different from Notepad or Word? Well, in this software, we have a number of different things. First of all, as you may see, our code that is here by default has different colors, okay? The public and class words here are in blue, whereas the my first script is in this turquoise color, and this stuff right here is in green, as well as white for these little parentheses. This is basically a way of highlighting certain parts of the code so it is easier to read for us. And also with these code editors is that whenever we are typing out our code, we have something known as IntelliSense or autocorrect essentially for coding. So it can help us fill in certain things that are more coding related rather than language related. So using a code editor like this is definitely the way to go. And if you install Unity, you should have Visual Studio install alongside that. So what are we looking at here? Well, this here is the code that comes default with the script whenever we create one. We have using Unity Engine, public class, my first script, void start, void update. What do all these things mean? Well, throughout the rest of the course, we'll of course be going over what these things mean and utilizing them to create the code that we want. But for now, just know that here where we have void start, this right here is a function. We'll go over what functions are in a future lesson, but a function is essentially a block of code which runs at a certain time. Now, void start gets called at the start of the game, and that means any code we put in between this opening and closing squiggly bracket will be run at the start of the game. Now, what I'm going to do is add in a new line of code. Essentially, this line of code is going to be executed, meaning the computer is going to read it and essentially do what we are telling it to do. So here I'm going to write in between the opening and closing parentheses of start, I'm going to write debug with a capital B, and then I'm going to go .log. Now, you'll see in this little window here, we have a bunch of different things popping up. These are all the possible things that we can write in our code. So if you are forgetting something, you might remember the first letter or something, it can tell you all the different things you can do. So a code editor is very helpful that way. So once I've written debug.log, I'm going to have an opening and closing parentheses. You should notice that whenever you create an opening parentheses, it is going to automatically create a closing one. And then in here, I'm going to add a quotation mark, so shift quotation mark, and it should create two of those as well. And in here, we can write something such as hello. Then at the end, we want to add a semicolon, okay? The semicolon is very important in programming and the C# language because that tells the computer that we are done with this command, okay? We are calling the debug.log command and ending it with a semicolon, basically telling the computer, okay, now do this. So what have we done here? Well, if we save the file by going Control S or clicking on the save icon up here, we can then return to Unity by just minimizing the window. Now, when you return to Unity, it is going to first compile the scripts. Essentially, it is going to convert the code from a written form into something the computer can actually read. And then what we can do is attach this script to a game object. Now, I'm going to go ahead and create a brand new cube just so that we have something visual on screen. Let's bring that cube to the center of our scene here, just so it's a bit neater. And to attach a component to a game object, we can do it in one of two ways. We can first of all go down to the Add Component button, and you may remember this screen, we have all the different components that we can go through and add, but if we search for My First Script, there it is, you can see it right there, and we can simply click on it to add that component. Alternatively, we can just click and drag the component onto the inspector here, and that will then add the component down here. So you can see, just like with the box collider, we have a little icon. We then have the component name, which is the name of the script file. And then down here is where we would have all of our different properties if we were then to add them later on. Now, if I go ahead and run the game, if I press the play button right here, what do you think is going to happen? Well, if we look down here at the console window, we should see a message and it says hello. So what we have done here with the debug.log command, or function as it's known as, is we are essentially telling the console to log a message, and that message was hello. So that right there is our first line of code. We are telling the computer to do something, and we essentially told it to log the message hello to the console. Now, in the next lesson, we are going to be looking at variables. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at variables inside of Unity, or more specifically, inside of the C# scripting language. So first of all, what is a variable? Well, a variable is a piece of data which we can define, read, and change the value of. You can think of a variable as a box. We can give a name to that box, such as player health, and then assign a value to that, which could be a number. This number can then be read by the computer. It can then be modified by the computer as well. For example, when the player takes damage, we might want to reduce that player health variable. And likewise, when the player takes damage, we might then want to check that player health variable to see if it is below or equal to 0, for example. Now, with variables, there are many different types that we can create. We can create variables that are whole numbers, decimal numbers, text, etc. There are a large number of different variable types, but for now, let's jump into Unity and look at creating our first variable. So in the previous lesson, we looked at creating our script. So what we're going to do now is open up that script. Simply open up Visual Studio or double click again on the script file down here, and we should then open up Visual Studio here. Now, we already have that debug.log command here. What I'm going to do is simply select it and delete it. Now, we're going to remain here inside of the start function, okay, where it says void start, inside and between the opening and closing squiggly brackets, because every bit of code written in here is going to be run at the start of the game. And what we're going to do is create a variable. Now, there are 3 things that you need when creating a variable. You first of all need to know the data type, which is basically telling the computer if this is a number, a piece of text, is it a decimal number, and then we need a variable name and then a value. So we always start with our variables by defining the data type. In this case, I'm going to create a variable that is a whole number. So here I'm simply going to go int, which stands for integer. This is a whole number. Then we go space, we write down the variable name, which in this case we might call it health. And then we go space, equals, space, and then we can give it a default value. So I might say 100. And then, since this is a command, we need to end it off with a semicolon, like so. Now, if you've done anything wrong, you should see a little red squiggly line somewhere around here. Don't worry about the green squiggly line. This is just telling us that we haven't actually used this variable anywhere. It's just a bit of a warning, but not an error. So we've created our variable. Now what we can do is, for example, log it to the console to see if it is successful. So I'm going to go to a new line by pressing the enter key, and this is going to basically take me to a new line. You can see on the left hand side we have all of our line numbers, 1, 2, 3, 4, 5, etc. So you can see we defined the health variable on line 8, and then on line 9 is where we are going to log it to the console. So here I'm going to write debug.log, and then in parentheses I'm going to write in the health variable and end that off with a semicolon. So what do you think is going to be logged to the console? Well, if we save the file, then return to Unity, we just need to wait for the script to compile. And once that is done, we can go up to the top and press play. And keep an eye down at the bottom of the console to see what happens. And there we go. We see that the number 100 has been logged to the console. This means that we are successful, okay? So if we go back to our script, we can see that we created the integer variable called health, gave it a value of 100, and then logged it to the console here. Now, the way and the order that you do this in is very important. Okay, this is known as the order of execution. Since computers are very rigid in how they work, they do things one operation at a time. And the same thing with your code. Code is written from the top down. So what we are doing here is we have first of all created our health variable, then we have logged it to the console. If I were to instead do something like this, where I log my health variable and then create it, you'll see I get this red squiggly line. And this is basically saying, as we can see here, cannot use local variable health before it is declared, because what we're trying to do here is log the health variable to the console before it is being created. And this is of course going to be an error because at the point at which the computer is reading this line of code, it doesn't even know that health exists. So, order of execution is very important. We have to declare variables before we actually use them. Now, what if, for example, I want to change the value of this variable? Well, what we could do is go to a new line once again, and we simply go health equals, and let's say 50, and end that off with a semicolon. Now what we have done is on line 10 is basically telling the computer to change the value of health. So health is no longer equal to 100, it is now equal to 50. And then what we can do is go to a new line and log that to the console again. So what we are doing here is 4 things. We are creating a health variable that is equal to 100. We are then logging that value to the output to the console. We are then changing the value to 50 and then logging that value to the console. So what we're doing here is in total logging 2 messages to the console. Now, before I press play, what do you think these are going to be? Okay, what do you think it's going to look like here in the console? Well, if I go ahead, first of all, make sure we have saved the script, return to Unity, and if I press play, what do you think is going to appear in the console? Let's have a look. And as you can see, it says 100, then 50, because remember, we changed the health variable. So that right there is a look at how we can create a variable. Once again, to create a variable, we define the data type. We then give the variable a name, and then with an equal sign, we give it a value. And then, of course, we ended off with a semicolon to basically tell the computer that we have essentially finished with this command and it should run. We are then logging it to the console so that value, the health value, is being displayed. We are then changing the health value by going health equals 50, and then we are logging that to the console again. Now, in the next lesson, we are going to be looking at creating variables with different data types. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at creating variables with different data types, because right now we have created a health variable of the type integer. This essentially means that the value of health can only be whole numbers, 1, 2, 3, a million, 256, numbers like that. But what if, for example, we want a variable that can have decimal numbers? We might want a variable that manages the player's move speed, and we probably want to have fine control over that. We might want the player to move at 5.2 speed, 5.21. We want fine control. So how do we define a variable like that? Well, to clean things up a little bit, I'm simply going to delete the last 2 lines of code that we wrote here, and then I'm going to go to a new line. So we still have our integer health variable, but now I'm going to create a move speed variable. So we start off with the data type, which is going to be float, and float stands for floating point number, or numbers with a decimal point. Then we can give the variable a name. I'm going to call it move speed, and then equals, we can give it, for example, 5.25, and then end that off with a semicolon. Now, you may notice that our number here has a red squiggly line below it. This is because we have not correctly defined a floating point number. To do so, after we write a decimal number, we have to put an F at the end to basically tell the computer that this is a float. Okay, and there we go. Now, you may notice that I've written my move speed variable a bit strange. Okay, I've written move in lowercase and then speed with a capital S. This is a general programming practice in C# known as camel case, okay? And this essentially means that whenever we are writing variables, we write the variables all in lowercase, except for the first letter of each word has a capital, except for the first one. So move speed will be written like this. If I were to have another variable called this item name, for example, it would be written like this. This item name, okay? Capital letters for each word, all put together with a lowercase on the first. This is just general practice with C#, like I said. Now, you may also be wondering, why don't we just have a space between move and speed? Well, that is going to result in an error because the way you type things inside of a programming language is very strict, especially with C#. Spaces are very predefined things that mean something. Okay, we put a space between float and move speed to differentiate that float is the data type and move speed is the name. Same thing for the equal sign and the value here. If we were to put a space between move and speed, that would result in an error because the computer all of a sudden thinks that move and speed are 2 separate things. Yet if they are together, it knows that this is the continuous name. So in programming, generally you will never use spaces for naming things. Rather, you will use capital letters like this. Maybe you'll even use underscores. That is also another option. So we have our move speed variable. Let's go ahead and log that to the console. So here I'll go debug.log, and then I'll log the move speed like so. And you can see when I'm typing out move speed, down here in the little pop-up window, it actually shows the variable. So if you are halfway through writing the variable and you see it highlighted in the list below, if it's not highlighted, you can use the arrow keys to adjust that. Simply hit enter and it is going to autofill that. So your programming speed can actually be quite fast doing it that way. Now, if we go back into Unity after saving, of course, we're going to compile the scripts. And if I press play, we should see, first of all, our health being logged, and then 5.25 for the move speed. Now, we can, of course, go ahead and change this value as well. So, for example, I might want to then go move speed equals, let's say, 5.5024F. Okay, you can be very precise with floating point numbers. They do have a lot of precision. So we could do something like this. Okay, now let's look at two other data types. The first one is going to be a string. So I'm going to write string, and then I might write, for example, player name equals, and then in double quotation marks, I'm going to write Bob, for example. So what I've done here is created a string variable. Now, a string variable is essentially text. So whenever we want to set or change this variable, we have to do so using quotation marks like this. Just like with a float, how we have to put an F at the end to basically denote this as a floating point number. For text, we have to put those in between quotation marks, okay? And you can see in the code editor, it actually changes the string to a different color, which is very helpful as it allows us to see where our strings are. Now, to change this, we could then go, for example, player name equals Tim, and that is then going to change the value of player name. What we can't do is go player name equals 5, okay? That is going to result in an error because we are trying to assign the number 5, which is an int, to a string variable. You can see here, if I hover over the error, it says cannot implicitly convert type int to string. And that's also another very helpful thing with this code editor. It is going to tell you exactly what is wrong with your code if you have written something that should not be, okay? Those little red squiggly lines, simply hover over them and it will tell you what is wrong. Now, the last variable type we're going to look at is known as a boolean, and a boolean is a variable that can be one of two values. It can be true or it can be false. So to create this, we're going to write bool for boolean, and then we're going to write game over for the variable name equals false. Now, you'll know that you've written false correctly because it is blue. Now, if we go ahead and write false with a capital F, that is going to be an error because we have to write it F-A-L-S-E or lowercase. Alternatively, we could go game over equals true. So game over can be either true or false. These are the only two values that you can set to a Boolean variable, okay? So with integers, we give them whole numbers. With float variables, we give them a decimal number with an F at the end to denote that this is a floating point number. With strings, we give them text inside of quotation marks. And with bool variables, we give them either a false or a true value. Now, there are many more different data types, but I would say these are the main four that you'll be using in your game development journey. Okay, so between now and the next lesson, I want you to go ahead and complete this challenge. I want you to create 4 variables to define a country. I want you to create a variable for the country name, its population, its highest altitude, and whether or not it's landlocked. You can, of course, Google to see if these values are true, to find for a specific country, or you can just make them up. But what I want you to do is have a different data type for each of these. I want you to use an integer, a float, a string, and a bool for each of these 4 variables. So have a go at that, and I'll see how you're done in the next lesson. Alright, so I hope you had a go at the challenge. Let's now hop over into Unity and have a look at how we can do it. So here inside of my script, what I'm going to do is go down to a new line here, and I am going to go ahead and create these 4 variables. So first of all, we need a country name, and I am going to use a string variable to do this. So I'll write string, then I'll write the variable name, country name, equals, and then in quotation marks, I'm going to go Australia, and end that off with a semicolon. Then for the population, since you can't have half of a person for a population, you can only have full numbers for a population count. I'm going to write int for integer, then go population equals, and then I might go 27,200,000 like so. Okay. Then we need to have a float for our highest altitude, because with things like mountains, you can have, for example, a mountain that is 2 kilometers tall. You might have a mountain then that is 2 kilometers, 3 meters, 26 centimeters, and 5 millimeters. So you can have those with decimal numbers. So here I'm going to go highest altitude equals, and then we might go 2280.5f, okay, just like that. And then finally, a boolean for whether or not the country is landlocked, because landlocked meaning is your country surrounded by water or not, is only a yes or a no, and Australia is going to be false. So there we go, that is how we can set up our variables for that challenge. Now, something else I want to go over in this lesson is the idea of comments. What is a comment? Well, we already have 2 comments inside of this script file. If we go to the top where we have our void start, you'll see there is this green text above, which, unlike the code, is written in typical English with grammar. Okay, and this right here is known as a comment. A comment is essentially a line that the computer does not read. Okay, comments are there for us humans to read and understand. You might have a function that does quite a complex thing that you might want someone else you're working with to understand, or later on, as you might forget how your code works, you might want to leave little hints or comments or notes as to how certain things in your code works. And that is where we use a comment. So to create a comment, I'm going to go down to where we have our 4 variables here. I'm going to go to the top and go //. You can see it turns green, and this means we are in essentially comment mode for the line. So I'm going to go space, and then I'm going to write challenge variables, okay? Just to know that, okay, these variables we made for the challenge. Now, this comment right here, challenge variables, is not code. Once we go //, anything we write on the rest of the line is going to be in green, meaning that we can write whatever we want and there's going to be no errors. The reason why is because, like I said, the computer doesn't read this line. Once the computer is reading the code, if it finds a comment, it simply skips over it because, again, the comments are not there for the computer, they are there for us humans to understand and read. You'll also see another comment down here which says update is called once per frame, and that is for the update function right here. And hopefully you'll be using these to leave little notes for yourself in the future as to how certain things in your code may function. Now, in the next lesson, we are going to be looking at different ways to modify variables by looking at operators. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at operators inside of Unity. So what is an operator? Well, essentially, operators are symbols that tell the computer to perform certain mathematical operations. These can be anything from addition to subtraction to multiplication to division. These are symbols that we want to use when we want to perform maths, essentially. Do we want to add a number with another number? Do we want to subtract something from another? That is when we use operators. So for example, let's just say we have an integer called num and it is equal to 5. And we then later on want to increase num by a certain amount. Well, we can simply go num plus equals 2. And that line of code will add 2 to num. So now let's hop over into Unity and look at how we can set these up. So here inside of our script, what we're going to do is we're going to start by creating a variable called score. It's going to be of type integer, so I'm going to go int score equals 0, and then end that off with a semicolon. Now let's just say the player is playing their game and all of a sudden they pick up a point or they cross a certain threshold. We want to increase their score by 1. To do that, we can go score plus equals 1. This right here essentially gets the number 1 and adds it to the score variable. So if I were to go ahead and now go debug.log score, what do you think the result will be? Well, let's hop over into Unity and press play. And as you can see, down in the console, it says 1. And that, of course, is because we are increasing our score variable by 1 right here. We can also go ahead then and do it again. We can go score plus equals, and let's say 5. Now, our score is going to be a total of 6 when we print it out here. Okay, so that is how we can increase our number that way. Now, we don't just have to use plus equals. What we could do is, let's say we have a variable, okay, or we have a couple variables. Let's say we have an integer called a equals 5, and then an integer called b, which equals 2. Now, let's just say we want to create another integer variable called c, and we want this to be the sum of a and b. Well, for this, we could simply go c equals a plus b. Now, when we define c, you can see we are no longer using raw numbers here to define that variable. Instead, we are using other variables. So what we are doing here is essentially going c equals 5 plus 2, because whenever we write A, we are referencing the number 5. Whenever we write B, we are referencing the variable B, which is a 2. So this right here is 5 plus 2, which is 7. We can also add as many additions as we want. We can go A plus B plus 2 plus 1,599. Okay, we can add as many pluses as we want, as at the end of the day, programming is very tangled with maths, okay? So we can use these mathematical operations to create some quite complex formulas for your games. Now, previously we went over the order of execution, which essentially means that our code is run top to bottom. So line by line, our code is going to be executed. So here where I'm going C equals A plus B, we'll just remove the other parts here, so it's just A plus B. This works because we have already defined A and B up here. But if I were to go ahead and move this line of code above, this would result in an error because, as you can see, cannot use local variable A before it is declared, because here we are trying to access A and B, but as you can see previously, no such things exist. We cannot use a variable until it has been defined, so we need to return this back to its correct position after we have defined A and B. Okay, so in the next lesson, we are going to be looking at a number of different operators to perform other mathematical operations. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to continue looking at operators. Now, first things first, I am just going to go ahead and add some comments. So here, I am just going to add a comment above this saying addition so that we can sort of categorize it easily when looking at our code. We can go, okay, this is where the addition is. Now what we're going to do is look at subtraction. So I add a comment here, subtraction. And what we're going to do is subtract 2 from our score. So how do you think we can do that? Well, essentially, I'm going to write score minus equals 2. And this right here is essentially going to do the opposite of addition. It is going to get the 2 and subtract it from score. So if our score is 6 at this point in time, our score after this line of code is going to be 4. We can also do it here where we have just the symbol to combine two things together. So we could go, for example, B equals A minus 3, and that will work just like that. We can also then look at multiplication. And for this, we might use a symbol that you are not too familiar with. Okay, so to multiply, you might think we go score x equals 5, but that is not the case. In programming, the multiplication symbol is going to be an asterisk. Okay, so shift 8 on your keyboard to add in the asterisk. This is what we use for multiplication. Now what we're doing here is essentially multiplying score by 5. And we can also do it like this, where we go B equals, and let's just say 2 times C, for example. Okay, so now B is equal to 2 times C. And then finally, we have division. So division right here. And for division, you may look at your keyboard and say, hey, there's not really a division symbol here. So what do we use? Well, for this, I'm going to go score, and I'm going to divide it by 2. So I'm going to go / equals 2. And that is going to divide score by 2. Likewise, we could go B equals, and then maybe go C divided by 4, okay? And that means B is now equal to C divided by 4. Now, we can also use operators with not just integers, but floats as well. So here what we can do is if we go down to a new line here, I'm going to create a variable called jump height, and let's set this to be 5.7f, okay? So our jump height is 5.7. Now what we can do is simply go jump height, and if we want to, for example, add 50% to it, we could just go multiplied equals 1.5f. So now what we're doing here is increasing our jump height by 50% by multiplying it by 1.5. We can also combine strings together with the addition symbol. So here I'm going to create a string variable called message, and this is going to be equal to a string, which might be hello, and then we might go plus and add another string, like so. So you can see with the strings, we can add them together with the additional symbol. but we cannot divide strings, we cannot multiply strings, and we cannot subtract strings either, okay? You can really only use addition with strings. And when it comes to Boolean variables, there's not really any mathematical equations to do with them, since that is just a binary true or false, okay? But operators, they are very powerful, and you'll definitely be using them all throughout your game development journey. Okay, now let's have a bit of a challenge. What I want you to do is create a money variable with a value of 10. Then what I want you to do is add 5 to it, double it, take 3 from it, and then halve it. I want you to use the addition, subtraction, multiplication, and division symbols in order to do this. So have a go at that, and I'll be right back in the next lesson to see how you're done. Okay, so I hope you had a go at the challenge. Let's now hop over into our script to begin looking at how to solve it. So here in our script, I'm going to go ahead into a new line. I'm going to add a little comment here, which is just going to be money challenge. And then I'm going to create an integer variable called money and give it a default value of 10. Now what we want to do is add 5 to our money. So we're going to do that with addition. So we'll go money plus equals 5. We then want to double it. To double this, we can use multiplication. So we can go money multiplied equals 2. That's going to double our money. We then want to subtract 3 from it. So we'll go money minus equals 3. We then finally want to halve it. So we'll go money divide equals 2. Okay, so dividing by 2 is going to halve it. And then finally, let's log it to the console. So we'll debug log money. And let's see if the value you got was the same as me. So I'm going to return to Unity here, and then what we're going to do is press play and see, hopefully, that we get the right result. And as you can see, we should get the number 13. Hey everyone, in this lesson, we are going to be looking at conditions inside of Unity. Now, a condition is essentially this thing that allows us to check to see if a certain statement is true or false. Now, with a statement, this is essentially something that we declare, and the computer tells us if that is a true statement or a false statement. For example, we can use the double equal sign for comparison. In this example here, I have 5 equals 5. That is essentially asking the computer, does 5 equal 5? That's correct, so that is a true statement. Otherwise, something such as 3 equals 7 is false because 3 does not equal 7. Now, with these statements, we then plug them into things that are known as if statements. If statements allow us to check to see if a condition is true. If that condition is true, then we run the encapsulated code. Otherwise, we skip over it. Because so far, we have looked at coding as one line after the other, no matter what. Whereas with if statements, this starts to allow us to branch our code, run certain things only if something is true. In a gameplay example, you might have a script that checks to see for when the player presses the spacebar. Then you might have an if statement that goes, if the spacebar has been pressed, then jump. Because you don't want the player to jump every single time that they possibly can, right? You only want the player to jump under a certain condition. And that is what we are looking at in this lesson. So let's jump into Unity and have a look at how we can set this up. Okay, so here inside of our script, what I'm going to do is start by creating an integer variable. And let's just say we call it score and we make it equal to 3. Now what we can do is have a piece of code that will log a message to the console only if our score is equal to 10. Okay, so what I'm going to do is write down if, and then have an opening and closing parentheses. This is where we then enter in our condition. So here I'm going to say score equals 10. Then I'm going to, on a new line, have an opening and closing squiggly bracket. That is just shift square bracket. Then go to a new line, and it should look like this. You have your if statement, an opening squiggly bracket, and a closing squiggly bracket. Now, when we click inside of these brackets, you should see that our code is indented. Our cursor is indented once. This essentially is there to make the code easier to read, okay? We now know that whatever code is written here is one indent in, so it is a part of this if statement. So anything we write inside of this if statement will only be run if it is true. And here I'm going to write debug.log player has won. okay, and end that off with a semicolon. Now, we don't end the if statement off with a semicolon because we are not having a statement here, okay? We are not declaring or telling the computer to run a command. We are simply asking them to check to see if something is true. So that is why we don't use semicolons at the end of if statements. Now, if I go back inside of Unity and run the game, what do you think is going to occur? Are we going to see that message logged to the console? Well, if I go ahead and press play, what you'll notice is that nothing is out here in the console. Why is that? We have the code written here, but it is not being written to the console. The reason why is because the condition has not been met. So you can imagine the computer. We're going line by line through this script. We reach int score equals 3, so we've now got a score variable that is equal to 3. We then reach the if statement here, and we are checking to see if score is equal to 10. Okay, score is 3. 3 does not equal 10, so this statement is false. Thus, the if statement does not run the encapsulated code, so it skips over this and it continues on with the next lines. But what if I go to score here and set the variable to be equal to 10? Well, now if we go back inside of Unity and press play, we should see that indeed we are going to get that message printed out to the console, as you can see here. So that is the basis of if statements inside of Unity. Now, it's not just equals equals, which is known as a comparison operator, that we can do. For example, we could do a condition that checks to see if the score is not equal to a certain value. So on a new line here, we can go if, and then score, exclamation mark equals 10. Then what we're going to log to the console, so we'll go debug.log. We will say player does not have 10 score. So what we are doing here is running another if statement, which is checking the condition score does not equal 10, exclamation mark equals. This is going to be true if the number on the left, which at the moment is 10, does not equal 10. Okay, so this is basically the opposite of the equals equals. So if we were to run this right now, this debug log message will run, but this one down here will not. If we set the score here to be 5, for example, then this debug message will not run, but this one down here will, because 5 does not equal 10. So hopefully you can see now how we can branch our code and run certain conditions to do certain things, as we are doing here. Now, there are also many other different operators we can use here. For example, if I go ahead and create an integer variable called health and set this to be equal to 50, I can then check a condition to see if the player is alive or if they've been destroyed. And we can do this by going if health is greater than 0. So what I'm doing here is I'm basically just checking to see if health is a larger number than 0 with the greater than sign. Then we can log to the console, player is still active. And then we can have another if statement down here, which could then go, okay, if health is less than 0, then we can say, or less than 1 actually, then what we can do is go debug.log, player has been defeated. Okay, so you can see how we can then use these different operators here to do that. Oh, and you see I have a little error here. That is because I forgot to put a semicolon at the end of this line here. So I can go ahead and do that. As well as the greater than and less than symbols, we can also use greater than and equals to. So this right here is going to be true if health is greater than or equals to 0. Now for this condition, we probably don't want that, but for this one down here, what we could do is we could go if health is less than or equals to 0. So we have a less than equal sign, then we can log the player has been defeated. So these are just a quick look at some of the conditional operators and conditions inside of Unity. Now in the next lesson, we are going to continue with conditions by looking at certain other things we can do with if statements. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to continue looking at conditions. Specifically, we are going to look at the else if and else statements. Because so far, we've looked at if statements, but there are a few more we need to explore. So what I'm going to do is create a variable called of type int, and I'm going to call it score. And let's give it something such as 75. Now, what we want to do is log to the console A, B, C, or D, depending on the score from 0 to 100. So what we can do is check to see, okay, if score is greater than or equals to 90, then that means the player has gotten an A grade. So we can go debug.log and then go, for example, A, like so. Now we can go, okay, if it is then greater or equal to 70, we'll give them a B score, okay? So here we can then go, if score is greater than or equals to 70, then we are going to log to the console B. Now, there is an issue with this code right here. Can you figure it out? Essentially what the issue is let's just say the player has a score of 95. Well, that means that they have an A grade. But since the code runs top down, we check this condition, it is true, so the code inside the if statement runs, but then we have this second if statement which runs as well, because the condition here is still true, 95 is greater than or equals to 70. So then this runs as well, but we only want the player to have one single grade, we don't want it to go A and B. So how can we fix this? Well, what we can do is use something known as an else if statement. And this is how we do it. Essentially what we're going to do is we are going to write the word else and then a space in front of the second if statement. So now what's happening is the computer is going to check the first condition. If this is true, then it's going to run the code inside the brackets. And if there are any else if statements beneath it, they are not going to run. The else if statements are only going to be checked if the first condition was not successful. So if, for example, our score is 75, this first condition here is not true, so the code in here will not run. So then what the computer will do, it will go, okay, let's then check the else statement. So else if this condition is true, run this code. Now we can of course stack these up. So for example, we could then go else if score is greater than or equals to 50, then we want to give the player a C grade. Okay, so once again, if I give my score to be 52, this first condition is not true, so it won't run this code. The second condition is also not true, so it won't run this code. Yet the third condition is true, so it will run this code. Whereas if I set my score to be 100, the first condition is true, so it's going to run the code, but since we have already successfully ran a condition, and it is true inside this if statement tree, you could call it, these other else if statements are not going to be checked, okay? Now, let's then finally say everything else, so anything below 50 is then going to be a D grade. Well, for this, what we could then do is go else if score greater than or equals to 0, then we can go debug.log and give the player a D, okay? But something else we can do is also known as an else statement. And what I'm going to do is simply remove the if score is greater than 0 here, so it simply says else. Now, an else statement is what we attach to the end of an if statement or an else if statement chain. Essentially, if the first condition is not true, the second condition, third condition are not true, whatever is encapsulated within the else statement will run guaranteed. So if our score is 20, for example, none of these conditions here will run, so the else statement will always run. You can essentially think of it as, if these things aren't true, then just do this, okay? Whereas if I set my score to be, for example, 60, the first condition is going to be false, second one is going to be false, the third one is going to be true, so it's going to log C to the console, but then the else statement is going to be skipped over. Okay, so that is how we can set up if, else if, and else statements inside of Unity. Okay, so as a bit of a challenge, what I want you to do is create a string variable called country, then using an if statement, check to see if the country is France. If the country is France, log to the console that it is France, but if it is not, log to the console that the country is not France. So have a go at this challenge, and I'll see how you're done in the next lesson. Okay, so I hope you had a go at the challenge. Let's now hop over into Unity and have a look at how we can set this up. So here on my code, I'm just going to go down and I'm going to add a little comment here, which is just going to say conditions challenge. And then what I'm going to do is I'm simply going to create a string variable called country. and this is going to be equal to, let's just say, Germany, then what we're going to do is we are going to have an if statement. So we'll go if country equals France. Then what we're going to do is we are going to go debug.log, this is France. Otherwise, we want to basically say this is not France, and we can do this simply by going else. And inside of here, we're going to go debug.log, this is not France. And there we go. That is the challenge complete. Let's now go to Unity and see if it works. So what I'm going to do is I am going to save the script, go back to Unity, wait for the scripts to compile. Then I'm going to go ahead and press play once this has finished. And we should see in the console that we have our number from what we were doing before. So we got an A, and then it says this is not France. So there we go. Now in the next lesson, we are going to explore functions inside of Unity. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be exploring functions inside of Unity. So what is a function? Well, essentially, functions are reusable blocks of code that we can tell the computer to run at any time. If we wanted the player to jump, we can call a jump function, which will change and make certain commands to the computer. If we wanted to have a function to basically turn on a light or turn off a light, we could have that set up as well. Now, already inside of our script, we have two functions that we have already been using. We have the start function, which gets called at the start of the game, and the update function, which gets called once every frame. Now, let's hop over into our script and have a look at these. So here in the script that we created, we already have two functions as seen here. We have void start and void update. Okay, start is a function which basically means that everything inside of these two squiggly brackets will be called once at the start of the game. Okay, and we've already been using that. This is where we have been putting all of our code, and when we press play, you notice that it gets run once, so we can see all the debug log messages. And down here, the update function, as you can see by this comment here, this gets called once per frame. So this is where you'll do things detecting player inputs or moving things over time. So, as a function is structured in a very specific way. We have what is known as the return type. This is essentially the data type that this function returns, because you can think of a function as having an input and an output. An input, these are known as parameters, and they get stored within these parentheses here. We'll go over those in just a second. And output, which is basically a result. Now for start and update, you see that their return type is set as void. This basically means that this function does not return anything, okay? We're not trying to get anything out of the start function or the update function, so they don't return anything. So we have void. And then we have the function name, which we can call whatever we wish. And then in these two parentheses here is where we put our parameters or our inputs. And for start and update, those don't have any inputs. And then finally, our squiggly brackets to basically define the bounds or the code that is inside of the function. Now, what I'm going to do is create my own function. So outside of the start and update function, I'm going to go to a new line and write down void. I'm then going to give my function a name, which is going to be called log2console. I'm going to have an opening and closing parentheses, which we're not going to fill in with any values, and then an opening and closing squiggly bracket. Now, all I want this function to do is log to the console that it has been called. So here we'll go debug.log, this function has been called. And there we go. Now, if I go back inside of Unity and I press play, you will notice that nothing happens. And this is because even though we have defined the function here and written it down, we haven't actually called it or invoked it yet, because a function by itself doesn't do anything. It needs to be called. Now, you may be wondering, where does start call? Well, that is called basically by Unity in the background. But whenever we create our own functions, you'll see it is currently gray, the name, which means it is not being called right now. So we need to call this function. And to do that, I'm going to go into start, and I'm going to write down the function name, log2console, and then have an opening and closing parentheses and end it off with a semicolon because we are telling the computer to do something. Now, if I save that and return to Unity and press play, you'll see we have that message successfully called to the console. So that function is now running. Also, if we go down and call it inside of update, so let's call that log to console function here. What you'll notice is that this function is now going to be called every single frame, which, depending on your computer, is going to be a very, very high number. So if we look down at the console, you can see it's going to be filled up, and we can see here the count. It's going 800, 1,000 plus. So that function is now being called every frame. Now let's look at how we can set up a function that returns a value and also has some inputs. Okay, we are going to create a function that takes two values, an A and a B value. It's going to add them together and return the result. So what I'm going to do is create a new function down here. It is going to return a value of type float. We're going to call the function add, and then inside the two parentheses, we want to add our parameters. These are essentially the inputs. I'm going to make these called A and B. So first of all, we define the data type, which is float. We're going to call it A, then we'll go comma, float B. And these right here are the values or the inputs. So whenever we call the function, we have to send over an A and a B value. Now inside the function here, I'm going to create a float variable called sum, and this is going to equal A plus B. And then you'll notice there is a red squiggly line underneath the name, and this is essentially telling us that we are meant to return a float value, but we are not doing that. So to return a value or output a value, we simply write the word return, and then we give it the value, which is going to be that sum variable. And there we go. We have now successfully created a function that has inputs and outputs. So what we can do is inside of start, I'm going to create a variable. We'll just go float, and I'm going to call this one number, and this is going to be equal to that add function. And remember, if I do my opening and closing parentheses, you can see here in the little pop-up, it tells us what parameters we need to send over, an A and a B, which are of type float. So here I might go 2.5, comma, and then I might go 3.77, okay? And end that off with a semicolon here. So essentially what we are doing is we are calling this function, and we are making that equal to the number variable. But you may be going, hey, this number is a float, not a function. Well, a good way to think of functions whenever we write this, for example, is don't think of it as a function. Think of it as a value, and that value is what this function is returning. So essentially we are setting this number equal to A plus B, 2.5 plus 3.77. And then we can go ahead and debug log the result. Okay, so now what we can do is return back to Unity, press play, and see what happens to the console. And there we go. We have the result printed out right here. So that is a quick look at functions. Again, a function is essentially a block of reusable code that can do specific things. Functions can have inputs and outputs. We define the output first, followed by the function name. Then inside of parentheses, we define the parameters separated by a comma. These parameters are essentially the inputs, okay? And then inside of the squiggly brackets, we write out all the code for the function, and then we can return a value if we are meant to be returning a certain value. Here, essentially in the add function, we are adding together the A and B parameters into a variable called sum. Then we are returning the value of that variable. Now, if you are creating a function that doesn't return a value, it might do something such as just jumping, which doesn't need to return anything, then you would have the return type set as void, okay? And also, you don't have to send inputs over either. As you can see in the start and update functions, these have just empty parentheses. So have a go at setting up some functions, maybe set up a function that can multiply, maybe set up a function that can do a more complex mathematical equation that might require multiple lines of code here. So yeah, just experiment with that. And in the next lesson, we are going to be exploring vectors. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at vectors inside of Unity. Now, first of all, we need to understand Unity's coordinate system. Okay, so to define a position in 3D space, we need 3 different values because it is 3 dimensions. We need an X, a Y, and a Z value. And using all those 3, we can pinpoint a position on a 3D graph. If this was a 2D game, we would only be using the X and Y axes. Now, vectors can be used for defining positions, directions, rotations, and scale. And if we hop back over into Unity, we'll see that we have actually used vectors in the past. If I select a game object, for example, and go over to the inspector, you'll see we have a position, rotation, and scale properties there, those variables. And you'll see each of them have both an X, Y, and Z value. This is known as a vector. A vector is essentially a variable or a data type which contains 3 different values, an X, a Y, and a Z. And the position defines our position in 3D space in terms of meters, rotation defines the rotation of the object in degrees, and scale defines the size of the object in a multiplier. Now, we can also access and modify these vectors inside of our code because this is a game engine. We are going to want to be able to move our objects around. We are going to want to rotate them. We're going to want to change their size in script. So we can do that. Now let's open up our script. And what we're going to do is inside of the start function right here, I am going to create a brand new vector variable. Now, the data type for a vector is going to be called vector3. Okay, and vector3 is essentially a vector with an X, Y, and Z. And I'm going to call this one new position. Then we want to go equal. And how do you think we're going to write out the X, Y, and Z? Are we just going to write, for example, 2, 3, and 4? No. We need to go equals new vector3. And then inside 2 parentheses here, we want to give the X value. So we might go 3, comma. We then give the Y. We might set this to be -2. Comma, and then the Z, which we might set to be 4. And then end that off with a semicolon. So right here, we have created a variable called new position. Its data type is vector3, so it holds an X, Y, and Z value. Now what we can do is set this to be our object's current position. Because remember, this script, the myFirstScript, is attached as a component to this cube game object. So what we can do is pretty much in our script go, okay, what is my game object, which is the game object we are attached to? What is that game object's position? What is their rotation? What is their scale? And we can modify those values. So what I'm going to do is on a new line here, I'm going to write down transform. This is going to give us access to all the properties and functions inside of that transform component. And then I'm going to go dot position. And then I'm going to simply go equals new position like so. So what I've done here is I've accessed my transform component dot position. So I'm getting the position variable or the position property from that component. And I am assigning it to be a new value, which is this vector right here. So now if I save this, return to Unity and press play, what we should see is that our cube, if we look in the inspector here, is going to move from 0, 0, 0 to 3, -2, and 4 on the Z. Okay, that's great. But again, this is a game engine and we want things to be moving, okay? We don't want things to just jump to a new position and not be able to see anything. So what we can do is instead of assigning a new position, we can instead increase that position by a certain amount. So what I'm going to do is I'm going to go up here, I'm going to rename new position to be movement, and then I'm going to change it to basically move along the x-axis. So here what I'm going to do is go vector3, 1 on the x, 0 on the y, and 0 on the z. So then if I go down to where we have transform.position, I'm going to go plus equals movement, okay? Just like with ints, floats, we can add, subtract vectors together, okay? Because at their core, they're simply 3 numbers, and these numbers are then going to be added or subtracted. So what we're doing here is now simply we are going to add 1 to its x position. And if I go back inside of Unity and press play, we should see in the inspector here that position value is going to increase by 1. Now, since we can increase the position, let's do it every single frame. Well, what I'm going to do is simply select these 2 lines of code, copy them with Control-C, delete them, and then paste them inside of update. Remember, the update function gets called every single frame. So now, if I save this and return back to Unity, what do you think is going to happen? Okay, if I press play, let's have a look. And what's going to happen is this cube is going to zip off the screen, and if you look at my X position, it is going up very, very fast. Okay, already we are at 3 kilometers away. Now, that's very fast, and generally in game development and Unity, you don't want to just be increasing movement by a certain number each frame, because think of it, if you're running your game at 30 frames per second, that means we would be moving at 30 meters per second. If our game was running at 100 frames a second, we would be moving at 100 times or 100 meters per second. So what we need to do is normalize this time. We need to convert this from a per frame movement to a per second movement. And to do that, what we're going to do is here where we create our vector 3, I am going to multiply it by time with a capital T dot delta time. Now, time.delta time is a float, and you can multiply vectors by floats. Simply, the float will be multiplied by the x, y, and z. And what we are doing here is we are essentially getting time.delta time, which is the time between frames. Okay, so the higher frame rate, the lower this number will be. This is a very small number. And what this does is it converts this vector and our movement from a per frame calculation to a per second calculation. So now we are not moving at 1 meter per frame, but 1 meter per second. So if I go ahead and press play, what you should see is our cube is going to move 1 meter to the right per second. And if we look in the inspector here at the X value, you can see it is doing that very thing. Okay, so we have the ability to move our cube around. Also, one more thing I want to go over is we don't have to define a variable whenever we want to use a vector 3. For example, down here with the movement, I could delete this movement variable here and instead go transform.position, let's just say minus equals, so we can subtract, and we'll go new vector 3, and let's say we want to move down, so it'll be 0 on the X, 1 on the Y, and 0 on the Z, and then multiply that by time.delta time. Now, you may be wondering, why are we going 1 if we want to move down? Well, remember, we are subtracting. So this here is essentially now a negative 1. So now what we can do is go ahead, press play, and we should see that our cube is going to move down at 1 meter per second. So there we go. That is a look at vectors inside of Unity. Congratulations on completing the course. We just finished having an introductory look at the Unity game engine. Okay, Unity itself is a very versatile engine, allowing us to create all sorts of games. And in the future, you can pretty much create whatever sort of game you wish using this engine, as it allows us to build to pretty much any platform. Now, in this course, we went over a number of things. We first of all went over installing the Unity Hub, installing the Unity Editor, creating a new project, and then learning about the Unity Editor. We then learned about GameObjects, the tools, parenting, prefabs, materials, lighting, physics, a whole range of different Unity features, which then allowed us to jump into scripting and begin learning to code from the ground up. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses, for people who are just starting out, or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Thank you very much for following along with the course, and I wish you the best of luck with your future Unity games.